Hi Adam. So I want to talk you through this Ring of Fire lab a little bit. Just give you a description of what we did. So imagine here's our lab table. We had a ramp that we set up coming down the table, and then we put a angle at the end. And we ran our ball bearing off that angle, so the ball bearing comes off like this. So you had, within your groups, two measurements that you were supposed to do. You were supposed to figure out the velocity that it comes off, and so to do that, we took a photo gate and we put the photo gate right here at the end of the ramp. And so if you know the diameter of the ball and the time it takes to go through the photo gate, you can figure out a velocity. Now that velocity is at an angle. So there's the other thing that we did, is try to measure the angle theta in here. So the students had to come up with this velocity and this angle. And I'm going to give you a little reminder because it's been a couple of days, but if we have that velocity at an angle, well then what we'd do is we'd find out how much of that velocity is horizontal and how much of that velocity is vertical. Once we have that, we can figure out, and we're going to call this right here the 0 point. We're going to figure out where do we need to put the exit ramp. So at what distance do we need to put the exit ramp so that the ball is going to land on the ramp over here. So basically we're doing a horizontal distance, and we're not worrying about how high this ramp is above the floor. We're going to call this our 0 point. So it's kind of like we're pretending it's going right from the ground. So you need to calculate the horizontal distance. You also need to calculate the maximum height. So I'm going to call this delta dV for the vertical distance, because on this vertical distance we are going to put our ring of fire. Okay, and yes, we literally in class lit that up. So what I'm going to do is I'm going to get you some data that can be used for measuring V, and I'm going to get you some student measurements from theta. The data for V is actually going to be probably the diameter of the ball and the time data going through the photo gate. So you're going to have, T1, T2. If T1 is 0 and T2 is 0.00123, well then you know that the delta T, subtract them, delta T is 0.00123, because subtracting 0 is nothing, seconds. And so velocity is distance over time, so you take whatever your diameter was in this amount of time, and that's going to give you your velocity at that angle. Break that down into components, and then you have to apply your projectile math. Remember our equations. Let's see, VF equals VI plus A delta T. Delta D equals VI delta T plus 1/2 A delta T squared. VF squared equals VI squared plus 2 I'm trying to remember. 2A delta D. Yeah, all three equations have acceleration. Now, I'm going to give you one more reminder. In the horizontal direction, there's no acceleration. So, in the horizontal direction, all of that stuff crosses off. And so, of course, VF equals VI. In the horizontal direction, it keeps moving the same velocity. So this becomes the only equation you have left to work on. In the vertical direction, you have to have an acceleration. You have to be using this in here. So if I were talking about vertical direction, I might use my VV, my vertical component, and I'll use that as my initial velocity in the vertical direction. And then I could say, well, let's see, how about this equation? I know the acceleration of gravity, and I know that in the vertical direction, if we're just going up and down, that my initial velocity upward is the opposite of my velocity downward. And so effectively, if I know one of these, I know both of these, and I could use that to find my time. Think about where the highest point happens, probably halfway through the trip, so think about that. I will get you some data, and I'm still going to expect you to show me the calculation, and you write it up as a mini lab. You give me an explanation of what you're doing and what you're trying to find, and then you show me your calculation, and your end result is you should have a distance and time. Now, the lab isn't set up anymore to try to do this. The students, when they got done, then they moved the ramp into position. They put the ring of fire in position. We soaked it with some methanol, lit it on fire, and we gave it a try. And we had some pretty good success from our student trials this year. Maybe I'll share one or two of those videos with you. So I hope that explains the lab, and I'll get you some data and let you get going.